Electricity, main thing everywhere nowadays. Without electricity, it is not possible to imagine at present world. So whatever, either lights, fans, TV, refrigerator, everything, whatnot, vehicles and everything. So that we should know that how the electric current will flows and how it will works. We can come through this chapter. Mainly here, through current carrying conductor, amount of the charge will flows, so electric current will produce that. So what types of the charges will be? Okay, here two types of the charges will be. One is proton, positive charge, that is 2 is equal to plus 1.6 into 10 power minus 19 coulomb, and electron negative charge minus 1.6 into 10 power minus 19 coulomb. So these two types of the charges will be. So we can tell that here current carrying conductor, in the sense in previous classes we learned that conductor in the sense which will allows that amount of the current to pass through it, such kind of things we can call it as the conductors. So here if you take that current carrying conductor, suppose generally it is a wire. Okay, in this wire, what happens in the sense that one in this current carrying conductor, free electrons it will be, so it will move freely. By that, the amount of the current will produce. Let's see that. If suppose if you see that in the, or if you zoom this current wire, then it will be like this. Okay, so the lattice ions, which means positive ions, will be in fixed positions, and free electrons will move in a particular direction. Why? Because here electrons only will move, but not the positive charge. Positive charge, which means lattice ions, will be in a fixed their position. Okay, when the free electrons are moving, then only it will produce. Suppose if you take that this is the current carrying conductor, as we mentioned that before, then what happens in the sense, if you take that A part and B part, it is in an open circuit. This current carrying conductor is open circuit. Then if you make it as two parts, then the amount of the charge is moving from A to B, and the amount of the charge which is moving from B to A will be that equal. When it is in open circuit, the amount of the charge which is moving from A to B as well as B to A, then we can say the net amount of the charge when it is in open circuit is zero. Then when it will be in the sense when it is connected to that particular source in the sense a cell or one or more than cells, if you use it, then it will send that amount of the electrons in a particular direction, we can say that. Let's see that suppose this current carrying conductor, we have given connection to that cell, then now what happens in the sense it will go there. This is the direction of the current. Now all the electrons will move in a particular direction. Okay, so then we can say that net amount of the charge is not equal to 0. Net amount of the charge is not equal to 0. Then we can tell that the amount of the charge passing through that unit area, if you consider that this unit area, in this unit area, in 1 second or in a particular unit of time, we can call it as the current. What is the current? Amount of the charge per unit time, we can call it as the current. The SI unit of the current is ampere. The SI unit of the current is ampere. The SI unit of the charge is coulomb, and SI unit of the time is second. So that we can say that how will you define 1 ampere of the current in the sense 1 coulomb of the charge passing through in 1 second time, then we can call it as the 1 ampere. So that we can say that in 1 coulomb of the charge, how many electrons will be in the circuit or current carrying conductor in the sense, let's find out them. So in 1 coulomb of the charge, they given as how much charge 1 coulomb, so that we can find out the number of the electrons from this. Okay, so then Q is equal to N into E. Q in the sense charge, N is in the sense number of the electrons, E in the sense electron. So that Q we know, an electron we know it's a fixed value 1.6 into 10 power minus 19, so that we can substitute in this and we can find out that the number of the electrons in this 1 coulomb of the charge, so that n is equal to q by e, then 1 coulomb by 1.6 into 10 power minus 19. Okay, then we can say that 10 power minus 19, if you send to that numerator, then it will be plus 90, then 1 by 1.6 into 10 power 19. Okay, then if you multiply here, numerator and denominator with the 10, then 10 by 16 into 10 power 19, then 2 5 and 2 8, then 5 by 8 into then 10 power 19. If you simplify this one, we can get that 0.625 into 10 power 8 19, then 1 digits if you multiply, then we can say that n is equal to 6.25 into 10 power 18. Number of the electrons will be in 1 coulomb of the charge. 1 coulomb of the charge, you can say. See that these number of the electrons are there in only 1 coulomb of the charge, you can get it. Okay, next coming into that potential and potential difference. Potential and potential difference. Okay, let's see that. Potential, generally, suppose to flow that amount of the water from high pressure area to the low pressure area, then only it can able to flow it. If it is a horizontal, it is a stable both sides, in a sense it is not possible to flow that. Is it right or wrong? So similarly here also, to flow the charge, something is required to push the electrons from one area, one place, one position to another position, we can say. Okay, so that what is the reason, in the sense here we can tell that it is some electric force required. Then how we can get that electric force, in the sense, suppose if you add that cell, okay, the source, that energy, that chemical energy, it will be useful to that push that electrons into one place to another place in current carrying conductor. Okay, suppose if you take that in an electric field, okay, this is a point, then something electron is here to bring the electron from infinity to something somewhere distance of out of the electric field. So from infinity to the point in the electric field, that we can call it as the potential, which means what happened here, the work done on the unit charge to bring from infinity to at a point, any point in the electric field. So we can call it as the potential. Then what about that potential difference? Let's see that potential difference. Potential difference, same thing, it is in electric field. In this electric field, suppose we consider that electron is moving from one place to another place, then we can say that the work done on the unit charge to move from one point to another point in electric field, that phenomena we can call it as the potential difference. That point we can call it as the potential difference. If suppose the same thing, you take the current carrying conductor, then this is the current wire, then what happens, the electron is moving from A to B. Here it is moving from A to B, here it is moved, which means how it is moved? By applying some force. Which force here applied? Electric force. So when the force is applied on the unit charge, then what happens, in a sense, it is displaced. It is displaced, which means it is moving from one place to another place. Then what happens? If it is displaced, in the sense, we can say that work is said to be done. Work is said to be done. So that we can tell that the potential difference V is equal to work done per unit charge. We can say that work done per unit charge. So the SI of the potential difference is a volt. So 1 volt is equal to 1 joule per 1 coulomb. What is the definition of 1 volt, in the sense of 1 joule per 1 coulomb of the charge? We can call it as the potential difference. This is differences between potential and potential difference, we can say. And next thing is very important in this electricity is, the topic is Ohm's law. Ohm's law. Okay, let's see that something if you take in a closed circuit, generally what happens in essence here we'll place one nichrome wire, okay, and then we'll take that one cell first. Then after what happens in essence one key and ammeter to ammeter in the sense to measure the current. Then we close this circuit. Okay, now this is the direction of the current. Across this nichrome wire will give connection to that voltmeter in the sense to measure the potential difference. Okay, so here one cell we added, which means how much in the sense 1 volt we added, for example. Then what happens in the sense current is flowing through this. Okay, then we observe that some amount of it is reading that. Okay, then suppose how much we take in here in the sense instead of 1 volt we can say that 0.2 volt. When voltage is 0.2, then current it is showing in this ammeter is then 0.1 ampere it is showing that 0.1 ampere. If suppose now we are adding that another 0.2 volt, which means how much total 0.4 voltage. So we are seeing that how much that it is reading ammeter. Ammeter in the sense it is the total reading of the circuit. So we can say that 0.4 voltage in the sense here it is reading that 0.2 ampere. Okay, like that when it is increasing that cells in this particular circuit, then here the current also reading is increasing. Current reading also increasing. So that we can say whereas voltage in this circuit is increasing in the sense current also it is increasing automatically. So we can say that the potential difference is directly proportional to applied current in closed circuit when temperature is constant. Here the condition is very clear, that is when temperature is constant then only the Ohm's law is valid. If not, in the sense it is not valid at all. So that we can say that V is directly proportional to I. The potential difference is directly proportional to the electric current when temperature is constant. When temperature is, suppose if it is not constant, then it cannot obeys. Did you understand? So we can say that for what it will obeys this Ohm's law in the sense, we can say that aluminum you can take, gold you can take. So like this copper you can take, these many things it is valid. Then for what not it cannot be valid in the sense you can take that gases and liquids, it is not valid. Why? Because when the current is crossing through that liquids and gases, it does not obey. So that we can say those are non-ohmic conductors. So here coming to this point, now V is directly proportional to I. Then V is equal to I into R. So R is what it is in the sense here it is a proportional constant. We can say that R is the resistance. R is a resistance. It is a proportional constant in this. So we can say what is the resistance in the sense it will opposes that flow of the charge. It will opposes that flow of the charge. We can tell that. Then next thing is how it will be the graph between VA graph, voltage and current graph, how it will be in the sense. Let's take that. Okay, on x-axis we are taking the current, on y-axis we are taking that potential difference. Okay, then each one it will be like this. Okay, each units if you take, then if it is ohmic conductor in the sense, it will be straight line. The graph will be straight line. If it is VA graph is curved in the sense this is a non-ohmic. Okay, this is a non-ohmic. Okay, so we can tell that for which one in the sense which does not obey that Ohm's law. How we can say it does not obey in the sense during that current crossing circuit when temperature is not constant, then in that situation we can say it is a non-ohmic conductors, we can tell that. Okay, from this we can find out that the resistance also from the graph. How will you find out in the sense? Suppose if you take that between any two values in the sense here you will take that. Okay, let's take that graph. We have taken that values. Same thing to draw that on x-axis. You can take that current. How many units we have taken in the sense 1, 2, 3, 4. 1, 2, 3, 4. And y-axis we take that potential difference. Then similarly 1, 2, 3, 4. Then here on x-axis current is 0.1 ampere, 0.2 ampere, 0.3 ampere, 0.4 ampere. And here voltage 0.2 voltage, 0.4 voltage, 0.6 voltage and 0.8 voltage. So that if you take that exactly at this point, okay, so like this you can draw that into mark. Then using the scale, here I am not using scale. Using scale you can draw the graph. It will become that straight line. From this graph, how will you find out the resistance in a sense? With using the slope formula, we can find out the resistance in a sense R is equal to, you can take between the any two limits. Okay, so we can say that this is I1, I2, I3, I4. So I can take that I3. Okay, so that we can say that V3 minus V2 by I3 minus I2. Okay, then V3 in the sense what is that V3 value? 0.6. 0.6 minus 0.4 by 0.3. I3 value 0.3 minus 0.2. Then we can say that 0.6 minus 0.2 in the sense 0.2 by 0.1, which means 2 ohms. Okay, so it's a unit of the resistance ohm, we can say. So 2 ohms, like this we can find out in one way. Another one way is what we can do in this, each limit you can take that this is R1, this is R2, this is R3, we can get 3 resistance we can get. By that you can take that average. From that we can find out that resistance we can say. Okay, so this is how to find out from the Ohm's law we can tell that.